in collections. Differentiate between collection and collections in the context of Java. In the java.util package, there is an interface called collection. It is used to represent a collection of separate objects as a single entity. It is equal to the container in the C++ programming language. The collection framework's root interface is referred to as a collection. It has a number of classes and interfaces for representing a collection of individual objects as a single unit. The sub-interfaces of the collection interface are list, set, and queue. Although the map interface is a part of the Java collection framework, it does not inherit the interface collection. Add, remove, clear, size, and contains are the collection's most significant functions. In java.util package has an utility class called collections. It defines various utility methods for working with collections, such as sorting and searching. All of the methods are static. These techniques gives developers much needed convenience and allowing them to interact with collection framework with more successfully. It provides methods like sort to sort the collection elements in a normal sorting order, and min, max to get the minimum and maximum value in the collection elements. What are the advantages of collection framework? Consistent API. The API has a core set of interfaces like collection, set, list or map, and all the classes like array list, linked list, vector and so on that implement these interfaces have some common set of methods. It reduces programming exertion. Instead of worrying about the collection's design, a programmer may concentrate on how best to use it in his program. As a result, the fundamental principle of object-oriented programming, that is abstraction, has been applied successfully. It improves program speed and quality by offering high-performance implementations of useful data structures and algorithms, as a programmer does not have to worry about the optimum implementation of a certain data structure in this scenario. They can simply use the best implementation to improve the performance of their program significantly. Explain various interfaces used in the collection framework. The collection framework has several interfaces, each of which is used to store a different sort of data. Let's understand one by one. Iterable interface. This is a collection framework's primary interface. The iterable interface is extended by the collection interface. As a result, all the interfaces and classes implement this interface by default. The interface main purpose is to provide an iterator for the collection. As a result, this interface only has one abstract method, that is iterator. Next one, collection interface. The collection framework's classes implements this interface, which extends the iterable interface. This interface covers all the basic methods that every collection has, such as adding data to the collection, removing data from the collection, clearing data, and so on. All of these methods are incorporated in this interface because they are used by all the classes regardless of their implementation style. Furthermore, including these methods in this interface guarantees that the method names are consistent across all the collections. We may conclude that this interface lays the groundwork for the implementation of collection classes. Next one, list interface. The collection interface has a child interface called a list interface. This interface is devoted to the list data, in which we can store all of the objects in an ordered collection. This also allows for the presence of redundant data. Various classes such as ArrayList, Vector, Stack and others implement this list interface. We can create a list objects with any of these classes because they all implement the list. Next one, queue interface. A queue interface, as the name implies, follows the FIFO order. There is nothing but first in, first out order of the real world queue line. This interface is for storing all the elements in which the order of the elements is important. When we try to shop a store, for example, the bills are issued on first come first serve basis. As a result, the individual whose request is first in line receives the bill first. Priority queue, DQ, array DQ and other classes are available. Because of these subclasses implements the queue, we can use any of them to create a queue object. Next one, DQ interface. It differs slightly from the queue data structure. DQ, also known as double-ended queue, is a data structure in which elements are added and removed from both ends. The queue interface is extended by this interface. Array DQ is the class that implements this interface. Because this class implements the DQ, we can use it to create a DQ object. Next one, set interface. A set is an unordered group of objects in which duplicate values cannot be kept. This collection is utilized when we want to avoid duplication of things and only keep the ones that are unique. Various classes such as hashset, treeset, linked hashset and others implements this set interface. We can create a set object with any of these classes because they all implement the set. The last one, sorted set interface. This interface resembles the set interface in appearance. The only difference is that this interface provides additional methods for maintaining element ordering. The sorted set interface is an extension of the set interface that is used to manage sorted data. Treeset is a class that implements this interface. We can create a sorted set object by using this class because it implements the sorted set interface. When you add a null element into a treeset or hashset, we can add null elements in a hashset, but we cannot add null elements in a treeset. The reason is that treeset uses the compare_to method for comparing and it throws a null pointer exception when it encounters a null element. What is priority queue in Java? When the objects are meant to be processed in the order of priority, a priority queue is used. A queue is known to follow the first in first out method. However, there is an occasion when the components of the queue must be handled in the order of priority, which is where the priority queue comes into play. The priority heap is the foundation of the priority queue. The members of the priority queue are ordered according to the natural ordering or by a comparator provided at queue construction time. Serializable, iterable, collection, queue interfaces are implemented by the priority queue class in Java. What do you understand about blocking queue in Java? Blocking queue is an interface that has been included along with the number of other concurrent utility classes such as concurrent hash map, counting semaphore, copy on write array list and so on. In addition to queuing, the blocking queue interface enables flow control by adding blocking if either blocking queue is full or empty. A thread attempting to enqueue an element in a full queue will be blocked until another thread clears the queue, either by dequeuing one or more elements or by clearing the queue entirely. It also prevents a thread from deleting from an empty queue until another thread inserts an item. A null value is not accepted by blocking queue. Implementation of the Java blocking queue interface are thread safe. Blocking queue methods are all atomic and use internal locks or other forms of concurrency management. There are two types of blocking queue in Java: unbounded queue and bounded queue. Let's understand one by one. Unbounded queue. The blocked queue's capacity will be set to integer max value. An unbounded blocking queue will never block since it has a potential to grow to very big size. As we add more pieces, the size of queue grows. Next one is bounded queue. The bounded queue is a second type of queue. In this case of bounded queue, the capacity of the queue can be passed to the constructor when the blocking queue is created. Explain fail-fast and fail-safe iterators. If a collection structure is changed, fail-fast iterators immediately throw concurrent modification exception. While a thread is iterating over a collection, structural alteration includes adding or deleting an element. Failsafe iterator classes include ArrayList iterator and HashMap iterator. Fail-fast iterators use an internal indicator called mod count, which is updated each time of a collection is modified to determine if the collection has been structurally modified or not. When a fail-fast iterator gets the next item, it checks the mod count flag, and if it discovers that the mod count has been changed after the iterator was generated, it throws a concurrent modification exception. If a collection is structurally updated while iterating over it, fail-safe iterators don't throw exceptions because they operate on a clone of collection rather than the original collection. They are referred to as fail-safe iterators. Fail-safe iterators include the copy on-write ArrayList and concurrent HashMap classes. Why do we need synchronized ArrayList when we have vectors, which are synchronized in Java? Vector is slightly slower than ArrayList due to fact that it is synchronized and thread safe. Vector's functionality is that it synchronizes each individual action. A program of preference is to synchronize an entire sequence of actions. Individual operations are less safe and take longer to synchronize. Vectors are considered outdated in Java and have been unofficially deprecated. Vector also synchronizes on a per operation basis, which is almost never done. Most Java programmers prefer to use ArrayList since they will not almost certainly synchronize the ArrayList explicitly if they need to do so. So these are the reasons why we need synchronized ArrayList even though we have vectors. What is the default size of the load factor in hashing based collection? The default load factor size is 0.75. The default capacity is calculated by multiplying the initial capacity by the load factor. If you like